Hello viewers, I'm Kausalya. Today we are going to solve problems related with RC transients. The problem is, in the circuit shown in figure, the switch is closed on position 1 at t equal to 0 and after one time constant it is moved to position 2. So find the current before and after moving to position 2. Assume no initial charge on the capacitor. So here this is the given circuit diagram, right? So initially the switch is in position 1 and after one time constant the switch is moved to position 2. So in this case we are expected to calculate the current, right? Current before moving to position 2 and after moving to position 2. And the thing is, there is no initial charge on the capacitor, therefore there is no initial voltage, right? So first we start our solution with when the switch is in position 1, right? When the switch is in position 1, just write the differential equation, right? So here let I is the current that flows through this circuit, right? So I into R plus 1 by C integral of I into dt, which is equal to a source voltage E, right? So here this is our basic equation. So the solution for this equation is, that is the expression for I of t is given by this expression, right? So here in this case, we can substitute the values, right? We know the value of E, that is 100. The value of R is 500 and again R and C. R is 500 and C is 20 into 10 to the power minus 6. So we know all the values, so just substitute it, and here we are finding out an expression for I of t. Okay, that is the transient current that flows when switch is in position 1. Right. So when you again look back at the problem, you see the switch is in position 1 at t equal to 0. Right. And after one time constant, it is moved to position 2. Therefore, what does it mean? The switch is in position 1 for one time constant, right? So here in this case, what is the expression for time constant? The expression for time constant is R into C, right? So here the value of R and C, everything is given. Therefore, the time constant is 0.01 second, right? Till 0.01 second, our switch is in position 1, right? Now, the current at t equal to 0.01 is calculated by, just now we had ended up with the expression, right? I of t is equal to 0.2 into e to the power minus 100t. So in the place of t, just substitute the values of 0.01 and here which gives the answer as 0.0736 amps, right? Now we are going to calculate the voltage across the capacitor, right? So the voltage across the capacitor is given by this expression, E into 1 minus e to the power minus t by RC. So here again in this case, right, just in the place of t, substitute the value as 0.01 second, right? So just substitute, we know the value of R and C, we know the value of E. Once you substitute and solve, here the final answer is 63.2 volts. Okay, this is the voltage across the capacitor, right? Now, the switch is moved from position 1 to position 2, right? So at t equal to 0.01 second, or we, instead of t equal to 0.01 second, we are giving it as a new name as t dash, right? So the switch is moved to position 2 during the time t dash, right? So again when you write expression here, that is now switch is in position 2, right? So look back at your circuit diagram. Now it is in position 2. So you have to consider only this part, right? So when you write the expression as usual, right, I into R plus 1 by C integral of I into dt dash plus, this is the voltage across the capacitor when the current I of t flows through it. So here the voltage is 63.2 volts, right? So here we are writing it as 63.2 volts, which is equal to, when you look at this diagram, you see the current flows from plus to minus here. Okay, therefore it is a negative voltage. So here it is minus 100, right? So again when you solve, you see our expression is like this. Okay, I am moving the 63.2 to the right hand side, therefore again that becomes minus. So minus 100 minus 63.2 gives minus 163.2. Again when you write down the expression for current, right, this is your expression for, that is for this kind of basic equation, this is your expression for current, that is I is equal to E by R, e to the power minus T by RC. So here in this case, you see this is your E and this is the value of R 500, R into C. This is your R and this is your C, right? So just substitute the values here. Once you substitute the value, you see finally we end up with this kind of expression. Okay, minus 0.3264 e to the power minus 100 t dash. So generally we are writing it as minus 0.3265 amps, right? So this is the current that flows through the circuit when switch is in position 2, and this is the current that flows through the circuit when switch is in position 1, right? So here comes the end of this problem. We will move with the next one. A capacitor of 2 microfarad with an initial charge Q0 is connected across the terminals of a 500 ohm resistor at t equal to 0. Calculate the time in which the transient voltage across the resistor drops from 60 to 20 volt. Here we have to calculate the time duration at which voltage across the resistor drops from 60 to 20, right? So here this is the given circuit diagram, right? So here we are having a resistor and a capacitor, and here the direction of the current is given, right? So here the thing is, you see there is an initial charge on the capacitor, therefore there will be initial voltage, right? So V0 is given by Q0 by C. So Q0 is given, the value of C is given, therefore the initial voltage is 100 volts, right? So when you write KVL, right, again you see 500 into I plus 1 by C integral of I into dt is equal to 100 here, because 100 voltage is the initial voltage developed across the capacitor, right? So here it is equal to 100. So the solution for this equation is again given by E by R e to the power minus T by RC. So here just substitute. We don't know the value of T. Okay, we are expected to calculate T. Therefore, let T remains as such. Now, the voltage across the capacitor is given by I into R, right? So here this is the expression for I, and what is the value of R? It is 500, right? Given in the problem. So once you solve, finally here we are ending up with the expression for resistance, okay, voltage across the resistor. Now it is given with two conditions, right? Initially the voltage is at 60 volt and again it gets dropped to 20 volt. So it is, the voltage is 60 volt when T is equal to T1, and voltage is 20 volt when T is equal to T2, right? So here just substitute the values. When you substitute 60, let the T be T1. When you substitute 20, let T is equal to T2, right? Now we are going to divide 1 and 2. So 1 by 2 when you divide, you see, just substitute the values, right? So 60 by 20 is 3. And here in this case, e power minus 1000 T1, here divided by e power minus 1000 T2. So again when you solve, you see I am moving this part to the numerator. So what happens? This minus becomes plus. So e to the power minus 1000 T1 plus 1000 T2, because since we are having the same base, right, we can add. And finally, when you take 1000 commonly outside, here our expression is T2 minus T1, okay, which is equal to 3 here. So this is our current expression. So once you take ln on both sides, finally the value of T2 minus T1 is equal to 3 milliseconds, right? Here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.